everyone. I think we'll get started now. My name is Lisa Kalla, and I am pleased to introduce Zachary Bleemer. I first met Zach in a presentation that he gave at the library last year about the data that he's been collecting. He's a PhD student in economics, and he's also a research fellow at the UC Office of the President. He's also working on the ClioMetric history project. He's the coordinator for that out of the Center for the Studies of Higher Ed. One of the really interesting things that I found sitting in his talk was the amount of data that he had that he's been kind of consolidating to answer the kinds of questions that he has in his role as economics. But as I sat there, a lot of the data that he referred to as he was telling the story really revolved around education, the choices that individuals make, especially things that are related to gender differences and the patterns of each of our campuses as we come to be. So without further ado, I recommended that Zach come here and talk with us in education because even though he's an econ PhD, he hasn't really made connections with social scientists or educators, and I thought this would be a wonderful opportunity for him to meet with us. So, Zach.
Thank you. Hi, folks. So my name is Zach Bleemer. As was mentioned, I'm a PhD student in the economics department. A lot of economists study education, and almost none of them ever talk to people in the Graduate School of Education or educators. I was really pleased when Lisa attended my talk in the spring and invited me to speak to you today. There's a sense in which I'm not sure which questions I could answer that will be of interest to you and which won't. I've done my best to cram a lot of different kinds of information into this talk, and I'll do my best as I'm moving along to get a sense of what's interesting you and what doesn't, and I'll move past things that don't. The general gist of this talk is to give you a sense of what education, higher education, has been like in the state of California over the past 120 years. And I'll give you a sense of what data I've been able to collect, what I'm able to know about education as it's changed, and what this means both for contemporary education and for the success of the state of California through the 20th and 21st centuries. So to start, I'll start with this general fact, which is that very little is known about the long-run outcomes that come out of higher education. There's a lot of study of students soon after they graduate university, identifying their wages, what jobs they accrue, how this changes social outcomes in their communities, how this changes marriage patterns, but not very much is known long after these students graduate college. The fundamental reason for which is that it's difficult to collect data about these alumni long after they've graduated. Especially in a contemporary age where digital big data is of extreme importance. Being able to follow these kids for 20 or 30 years, first of all, just requires student records from the 80s and 90s that can be matched to contemporary records, which in many cases don't exist. So the initial motivation of this project was just to get a sense of how higher education has long-run implications for students. And then it's fallen into a couple of other sort of facts that have sort of come up more recently as I've been working through this project. First is the plight of public higher education in the state of California. Enrollment and graduation rates have stagnated. Costs, in particular tuition costs, have increased. One reason being a disinvestment by the state. And getting a better sense of the contributions of higher education, both social and personal, I think is really valuable to justify the continued growth and success of public education in the state. And finally, there's this, I think, somewhat convenient fact from my research, which is that next year is the 150th anniversary of the University of California. This gets administrators very excited about any information about the university's history. The idea, the research agenda that's come out of this motivation is what I'm calling a ClioMetric history of higher education in the state of California. Clio was the Greek muse of history, so ClioMetric is just the application of statistical methods to historical data and historical subjects. This project has three central components, the first of which is large-scale data collection. The second of which is visualization of that data, just to describe changes in higher education over time in the state of California. And the third is statistical analysis. I'm a statistician by trade. The idea is to use these large data to perform causal inference and learn about the difference, the ways in which universities have changed people's decisions over time. This project has a lot of prongs. The primary three of which that I'm working on right now are first a study of socioeconomic mobility through the last 100 years. To what degree do universities contribute to bringing people from a lower class to a higher class, economically but also socioeconomically? And so how do universities sort of play this role in particular the state of California, which has been long known to have extraordinary socioeconomic mobility? Second is a long-run project on the budget of the university. We'll have a working paper out within the next couple of weeks, just studying changes over the last 30 years in how public universities in the state have been funded and how changes in those funding models have changed student outcomes at universities. And third is a specific study on medical education in the state of California, looking at how doctors' education has changed. And how, in particular, the elimination of affirmative action in medical school applications has affected the types of doctors that are being trained and has affected care quality in various communities across the state. I'm not going to have very much to say about that project today because of holdups in institutional review board process. So I'll mention that some of the data that I've collected is private. That data is protected by FERPA and so requires institutional review, despite the fact that it's secondary data. I'm not collecting it directly from individuals. And so for that reason, there's a lot of contemporary information that I'm not permitted to share. It's for that reason that I'm going to focus today mostly on the first half of the 20th century, because those records are publicly available. So the goal for today's talk is threefold. I'll just give you a sense of what data I have collected about universities in the state of California for the last 100 years. I'll also give you a sense of how I've collected that data. Most of this data was originally collected in books that was digitized by libraries and then I've processed into a large computer-readable database. I'll give you a sense of how that works. I'll share some descriptive findings of universities through the 20th century. And then I'll focus on a particular study that I thought would be of interest in this crowd, which is the impact of female high school teachers, particularly chemistry and physics teachers in the early 20th century, as role models in rural California communities, pushing young women into university when only 5 or 6% of women were attending college at all. So, I'll start with data collection. I should quickly say, in economics talks, we never get through more than like 6 slides because people ask you so many questions that you never actually get to say anything. There's benefits and costs to that model, but please, if anyone has any questions throughout, just raise your hand. We've got plenty of time, and I'd love to hear about it. So, how well can you see this? Pretty well. So here's a figure that gives you a sense of the 3 varieties of data that I'm collecting, at least the primary varieties, and the schools from which I've been able to collect this data. So if you look on top here, this represents 5 schools from which I've been able to collect student directory information. This means students' names, their majors, their years of attendance and graduation, and the town that they came from before they went to university. You can see, so for instance, this top logo is the University of California. And so I have public student directory information for students at the University of California from 1893 until 1946. Then those records go dark for about 40 years and pick up again in 1999 to present. So that's what I have for the University of California. Stanford, I have a similar early stage information. Caltech, same thing. Caltech wasn't founded until the early 1910s, so of course I don't have student records before then. But I have complete Caltech records until the late 1940s. Mills College runs up until the late 1930s, also from the foundation of the college. And then sort of faded out here, you can see I have 30 years of USC data. After 1923, USC has kept their records copyright protected, so I can't say anything about USC past the time, but I'll give you a little bit of information about that university before 1923. It turns out it's a very interesting college. Okay, so I have just lists of names for those universities, yes.
Is there a reason why?
Oh, yeah. So the records, for the most part, stop in 1946. These records are student directories. The idea was that you could look up your friends and find local addresses. In 1946, there were about 14,000 students at the University of California, Berkeley. And in 46, the war ends, the GI Bill is implemented, and student bodies grow tremendously. They grow too much, so they actually stopped publishing these directories in 1946 because the books got too long. So they replaced them in the 50s with phone books. But phone books don't have very much information. They don't have where the kid is from, they don't have the student's major. So this variety of information, in sort of a quirk of technological progress, was removed from the historical record. Eventually, this will be able to be filled in by student transcripts, but those I can't share. So that's the student directory information. The second set of information is a directory of faculty and courses. So these come directly from course catalogs that were digitized by universities. And the way these course catalogs worked is that they would list the department name, then they would list all of the faculty in that department by rank, and then they would list all of the courses in that department. So this is just an analytical processing task to take this book, extract the information that you want into, you could imagine, a very large Excel spreadsheet where each row is a course, and then a second spreadsheet where each row is a faculty member. These faculty members that can then be linked over time to give a sense of when someone starts as faculty member at the university and when they end. Moreover, these records are available for Berkeley, UCLA, and Davis, as well as Stanford University from 1900 up until the early 2000s. So in the early 2000s, again, technological change occurs. They stop publishing course catalogs in favor of online course registers. And again, there's information loss. So it turns out that online course registers don't have lists of faculty, for which reason these faculty lists become unavailable. It's very difficult to find a complete list of Berkeley faculty. You can do it in wage records, but those kinds of like Sacramento Bee records don't exist for someplace like Stanford. I actually don't think there is an available list of Stanford alumni, faculty currently available. So that's a second set of data. And then a third set of data is student transcripts. So I had a team of 6 research assistants last semester who were scanning all of the student transcripts of UCSF students, 1890s to present. I have a current team that's scanning all of Berkeley's registrar, and I'm just starting to work with San Jose State University to digitize their student transcripts. So this will eventually give a tremendous amount of data about university admissions, about attendance and activity while at the university, and then can be linked to alumni records to tell us about what happens to these students. But most of these data are not yet available, and those that are, I won't be saying very much about today. So nevertheless, even excluding student transcripts, there's a lot of data to look at here. So it turns out there are about 750,000 student years in this database from the 1890s through the 1940s. This captures a little more than half of the higher education market in the state of California. So USC is the largest school that's missing after the 20s. Up until the 20s, the largest school that's missing is Pomona, though the University of San Francisco is growing pretty consistently through this period. There are also a lot of strictly theological, law, and business schools, many of which no longer exist, that had small numbers of students at the time. But I'm capturing all of the large and most of the mid-sized universities at the time. There's a lot of student transcripts, right? There's some 60,000 faculty at these 4 universities over the past 100 years. Over a million, that's not right, over 800,000 courses by course year have been taught at these 4 universities in the last 100 years. And then there's a tremendous amount of other data, some of which I'll be talking about later. Registers of all of the high school teachers in the state from 1906 to the late 1920s. Registers of all doctors from 1903 until 1956. Everyone who went to the First and Second World Wars, everyone who owned a vehicle, anything that was recorded in a book has likely been scanned by some library and stuck into a database, which means that I can turn it into data that can be used for social science. How does that process actually work? So here on the left, you have an anonymized student transcript. On the right, you have one of these pages of a student register. So what these registers look like, you can see there's a person's last name, first name, their local address, their year in school, their major, and the town that they come from. these anonymized transcripts have similar information. So I've blocked a lot of the information out. You can imagine that there would be a name on top, there's the town that they're from, there's a birth date. They have the date that they're admitted to the school. If they have prior degrees from other universities, those would be listed. The transcripts, of course, also include the courses and grades that a student has received, though honestly, at least at this stage of the process, I think that information is much less interesting than the demographic characteristics of these students. And finally, in the transcript, you can see when they graduate. So you've got this information in an image. The first step after you've taken the photograph, you have the image, is to use proprietary software to extract information in the sense of just literally these programs find letter by letter all of the typewritten letters on the page and tell you where those letters are on the page. So you can imagine you're sort of processing the image into a long database that gives you the coordinates, X and Y, of every letter on every page. You push this through multiple programs because each program has some error. Sometimes it reads an A as a B, etc. Sometimes it leaves out letters altogether. By using multiple programs, you can, with almost perfect accuracy, find all of the letters on the page. And then the step after that is something ugly. So imagine these really ugly programs, the job of which is to tie letters together into some sort of format that a computer understands. So what these ugly programs roughly do is find the start of lines and then find the first word after the start of a line, and it says, oh, that first word is probably a last name. If it's followed by a comma, whatever comes after the comma is probably a first name. Look for a dash after the dash is the location, etc. You're just teaching the computer patterns, and then the computer is applying those patterns to the text to get an idea of what information counts as what, so that you can end up with a large database. So, okay, so now you've ordered the data in this way. The next thing you can do is conduct inference on the data that you've ordered. You can, for instance, match first names to standard Social Security records. So the Social Security Administration, this is not a one-to-one match. The Social Security Administration just lists, say, how many Erics were born in a given year, and how many of those Erics were male. If there's some name that is 10 times more likely to be, say, male than female, you can assume that people born in that year with that name are male. So you assume people's gender based on their name. There are probably concerns, especially today, with androgynous names and names that are relatively unusual. This is much less of a problem in 1910, especially among college goers in 1910. These are almost all white people. I'll show you, there's a little bit of heterogeneity, but very little. And almost everyone has a name that is at least 10 times more likely to be one gender than the other. So you match the genders, you match the hometown to coordinates of that town so that you can map it. The coordinates come from the best database of towns available, which is called GeoHack, which is just actually Wikipedia. So town coordinates come from Wikipedia. You can link names over time to see when a student starts at the university and when they graduate, if they graduate. And finally, you can machine learn ethnicity from their names. That's a task that's still ongoing. I'm not going to show you results there today. And finally, what have you got? You've got this long list of names. These are people. These people appear in a lot of other historical records. This is a page from, I think, the 1940 US Census, which has been completely digitized by Ancestry.com. Ancestry has digitized all censuses back to 1890 and up until 1940, so you can find all of these students in the census to get information about their parents or information about wages after they graduate. You can link them to these CABI and CADI databases. These are public databases made by the state of California that list every birth and death that occur in the state. The death records actually publicly match individuals to their Social Security number, which is very useful both in identifying deaths as well as then linking those Social Security numbers to other records. There are these teacher and doctor licensing databases that I'll show you that give a sense of the person's profession, as well as registered motor vehicles, drafting into the First and Second World War, etc. You know a lot of information about these kids. Yes?
Does that data allow you to identify how people who are named whatever era actually identify themselves in the census, since the census is self-reported?
Yeah, good question. So the census hires thousands of people to knock door to door and try to find everyone, but there are people missing. It's well known in the literature of sort of linking to the US Census that there are an extraordinary number of missing people, and we're not exactly sure what to do about them. So in my case, I match about 65% of students to the census. Those other 35%, there's a couple of possibilities. They could be dead. They could have emigrated out of the country. They could have, in the case of women, they could have changed their name in a way that I can't always identify. So I have marriage records for the state of California, but if you got married outside of the state, then I can't see your now given last name. And there are some people who will be missing from the census altogether. So I can give you a sense of which people are missing, but there's a lot that I don't know about under what circumstances people were not captured.
Well, my question is,
Yeah.
can you tell us how the people who we've captured
Yes.
have identified themselves ethnically?
Oh,
Racially-
okay. I'm
racially
sorry.
in the
I
census,
understand.
you know,
Yes.
African American
Yeah.
has identified him or herself.
Yes, absolutely. So yes, for the 65% of people who are captured in the census, over 99% of them are white. Of those who are white, this is at a time when Irish and Italian were still relevant ethnicities within whiteness. So you can see where these people's parents were born and identify them as Irish, Italian, etc. In that way. I haven't done very much work there. And then for the remaining 35%, you can essentially just sort of guess based on their name. That's it. Yeah. Okay. So here's what you end up with. You end up with a really long spreadsheet. You assign individuals identification numbers, you have their name, you have the year in which they're observed in, say, a student register, what year they were in school, what their major was, where they come from, and then you have all this information that you've learned about them from alternative sources. So, one more thing. So the next step, it seems, is to learn something from this. The last thing that I'll show you before actually visualizing this data is a graph showing you quality. So I don't know, I think it would be legitimate to feel a lot of concern here. What have I done? I've taken pictures of books, I've pushed pictures of books into a database using an extraordinary number of proprietary OCR software. I've then made up some fancy algorithms that, I don't know, organize this in such a way. Is the result actually of interest? Is there anything real in there? So here's the degree to which I can show you that what I will visualize for you is real. This chart on the left shows in blue the number of students that I capture at the University of California, Berkeley, from, I think, this goes from 1908 to 1938. And in red, I compare this to statistics published by the university in that year. There was a statistical addendum published in these registers throughout this period. You'll see there are 2 years in which the statistical addendum was not published. This is the start of the First World War. And there seemed to be a lot of cutback, so the statistics unit did not produce numbers. You can see, nevertheless, there are sort of 2 places in which I'm erring. So first here, the student registers seem to have more students than published statistics in the early 1920s. And then in this late period, in the late 1930s, the student registers seem to have less students than the published registers. Otherwise, the 2 map together very closely. This story, I think, is pretty easily explainable. What's happening here is that students are arriving at the university faster than the statisticians can count them. Right? There are literally more students being listed as belonging to the university following the First World War than there were counted students, according to the statisticians. The only way this can be explained, for the register to be larger than the statisticians, is for the statisticians to be erring. This is a more substantial problem, right? So this is a case in which there's a problem in the books that have been digitized. Every once in a while, for whatever reason, in the late 1930s, there are these errors where a certain page will appear upside down, or a certain page will appear in a slightly fuzzy way, and so I'll lose an entire page of students. So you can see that about 5 or 6% of students go missing in these late 1930s. I don't think this is something to be particularly concerned about. It's a random selection of students who are missing, arbitrary pages that are misdigitized. And then here on the right, so this just plots again in my data and actually the proportion of females in this database. So remember, proportion of females here, what that really means is I'm matching people to social security records based on their first name to see whether they have a male or female first name. And you can see that the proportion of female students is almost exactly lining up. Again, excepting this period in the early 1920s. You can see that at this time, the actual statistics suggest that there are more, more men than it appears there actually are. I think this is an error on the statistician's part. Despite the fact that I'm missing some students in the late 1930s, I'm missing them at least randomly according to gender. So I'm missing an equal number of male and female students, proportional to the number of male and female students at the university. That's all I'm going to say about quality. You can do similar plots on, say, the proportion of students who are in the first year or the proportion of students who are in the letters and sciences. Trust me, they all look basically like this graph. There's some weirdness around the First World War. Otherwise, they line up just about perfectly. Okay, how's the time? Good. So I'm now just going to show you a couple of charts that just visualize what higher education was like in the first half of the 20th century, in some cases comparing it to today. Starting with gender. So there are 3 lines in this chart: Berkeley, Stanford, and USC. This is the proportion of students who are female from the early 1890s through the 1940s. So I think the first thing you should notice about this chart is that as early as, say, 1900, the number was not 0. Indeed, it was nowhere close to 0. And indeed, there's no sense in which there was like some long-run trend upwards in the proportion of students at California universities who were female. That long-run trend upwards is the case if I were to continue this after 1940 to present. So since 1940, the proportion of students at universities has been steadily increasing in women until today, when about 55% of undergraduate students are female. This was not the case in the early 20th century. In the early 20th century, a stagnant approximately 40 to 45% of students were women. This is true not only at the public university, but also at these 2 private universities. Now, you'll see USC is actually much more female than the public university. This is unusual. For a private co-ed university to be majority women, it's unusual across the country. Unfortunately, their data ends in 1923, so I can't say very much about what happens in the 20s and 30s. Stanford, on the other hand, you can see, has this steadily declining proportion of students who are women until this year, 1932. This is a peculiarity of Stanford University. So Leland Stanford's wife, upon her death, in her will, stipulated that no more than 500 students, undergraduate or graduate, could be women. And indeed, all those women had to live in a single dormitory on campus. The will was overturned in 1932, but Stanford is steadily growing during this time, and the number of women at the university is fixed at 500. So in this year, the will is overturned, and you can see the school returns approximately to the same level as the University of California, but that explains this somewhat peculiar decline. So that's what's happening in the gender distribution of students. Where are these kids coming from? Right, the rough answer is they're coming from all over the place. So I'm only mapping the state of California here. About 7% of students, a little higher actually, almost 10% of students were coming from out of state. I'll show you that in a second. But it's not the case that universities were like primarily or wholly serving the large urban areas of the state. The University of California had a very large agricultural school and eventually moved out to Davis, but it started here at Berkeley. And so you can see, even in 1900, a very large number of students are coming from the Central Valley. There's a lot of growth from 1900 to 1930 in Los Angeles. This is for 2 reasons. One is that the population locus of the university the state, really did switch from San Francisco, by far the largest city in 1900, to Los Angeles, which was the largest city by the 1930s. A second change is the opening of UCLA, which opens in 1922 as the southern campus of the University of California, and eventually breaks away from Berkeley in the 60s. So really what I mean for you to take away here is these students are coming from all over the place. Moreover, the color coding here is color coded by gender. And so darker means more women. So you'll notice that again, it's not like all of the women are coming from big cities and rural areas are sending their men to college. On the contrary, there are a tremendous number of women from the Central Valley who are attending college. Women from rural areas in 1900 who went to university. This is at a time that only about 5% or less of all people, and even maybe about 4% of women attended university. So a chart on residency. So here I'm breaking students into one of 4 categories. Either you come from a rural area, which means your town has fewer than about 2,500 people, or you come from an urban area, or you come from out of state or out of country. So there are 4 bands here. You can see the proportion of students from rural areas peaks here in the late 1900, early 1910s at about 25%. And does steadily decline, though as late as the 1940s, still about 15% of students come from rural areas. It's worth noting that the proportion of all California residents who live in these rural areas peaks here at just above this at about 30%, and is also steadily declining along with this line as California urbanizes. The vast majority of these students are coming from urban areas. And then you can see, let's see, so here, about 17%, this remaining section of students came from outside the state of California, with only about 2 or 3% of students coming from outside the country. And that number shrinks a little bit, but again, in 1940, it was about 20% of students. This is for all of the universities in the sample. If I just plotted it for the University of California, the same would be true. There have been a lot of recent battles over the proportion of out-of-state students at the university. And there's this notion that Berkeley, which is currently at 25% of undergraduates, is at an unusually high level of students who are coming from out of state. I don't know, Berkeley, even in this period, so 50, 60, 70 years ago, had as many as 15 and usually averaging around 12 to 14% of students who are coming from out of state. This is nothing, it's not a new phenomenon at the university. A next thing that you can look at is what's called the name score of these students. So this is a somewhat peculiar metric. You should take it with a grain of salt. Think of this as a stereotype measure. You hear a person's name and you guess based on their name how much money their parents make. So the way that you're going to make this guess is by looking at, say, all of the Freds in the country. Look at the Freds when they were kids. See the parental income of Freds, take the average parental income of all Freds, and then push that forward to guess that our Fred today grew up in a family with that level of income. This is a very peculiar measure, and all I can suggest to you is that it's somewhat informative. I'll show you evidence of its being somewhat informative in a moment, but even theoretically you should see that rich families and poor families name their kids differently. There's cycles in this, right? So poor families will often give their kids names that rich families gave their kids, say, 15 or 20 years later. So you have to sort of follow these cycles. For each person, you look at the names given by people like them, I don't know, say 15 years earlier when they were born, and then pull this forward based on their age. So, taking it with the grain of salt that you should, what this shows you is for men and women at Berkeley and Stanford, the average name score of these students relative to the average across the state. So 0 here, if these lines were at 0, that would mean that these kids grew up in the same class of families as the average in the state. So you can see that these numbers are above 0. That's to say the kids who went to college in the early 20th century were richer than average. That's unsurprising. Maybe somewhat more surprising is that the degree to which women attending college were richer is much larger than the degree to which men were richer than average. So moreover, you can see Stanford women are substantially wealthier in the sense that their parents earned more money based on their name than students at UC Berkeley. And you can see there's a gap. The gap exists as early as, say, 1907, 1908. But it widens a lot here in the early 1920s and continues to be quite wide. Same thing for men, the gap is smaller, but starting in the early 1920s, Stanford men are perpetually a little bit wealthier on average than Berkeley men. You should take this, I think, as a bit of a validation exercise for the name score. Stanford didn't charge tuition until 1923. Up until 1923, Stanford and Berkeley essentially cost the same amount. Starting in this year, Stanford started costing more. And you can see that as soon as Stanford starts charging tuition, the degree to which Stanford students are wealthier than Berkeley students increases. If I were to plot, say, Mills College and Caltech here, two single-sex private universities that charge high tuition, both Mills College and Caltech students are substantially wealthier, male and female, than students at Berkeley, the public university at the time. UCLA and Berkeley look essentially interchangeable. Okay, so that's what's happening with class. Next is a question about majors. So here on the left is the distribution of majors. This is specific to UC Berkeley in 1900. So you can see about 10% of students study the humanities, 40% of students study the social sciences. This is where most of the women are. So in economics, in psychology, in sociology and anthropology, there were some women in the humanities, there were some in the natural sciences, but primarily they were focused in the social sciences. It's worth noting that the first female faculty member at Berkeley was in the economics department, and the social sciences in general had many more female faculty than any other program at the college. These top majors, the health sciences, which is largely pre-medicine, engineering, and then at the top is business and other professional schools, which was largely architecture. Those colleges are almost wholly men. It's worth saying that the colleges were technically open to women. Berkeley had no restrictions on gender in any major from its founding in 1868. Here and there you do see, for instance, a woman in the College of Engineering and the College of Chemistry, but it's very rare. That's, of course, not the case now. So these charts today, this is the major distribution at Berkeley in 2000, and here it is in 2014. So the first, I think the sort of most striking thing to notice here is the growth of the professional schools. So assuming that you consider everything above this line, professional schools, they've expanded pretty dramatically since 1900. I'll show you in a moment that you can see that in both the faculty and course distribution of these schools since this time. That's how majors are changing. Now, using these links to the US Census, I can tell you some information about what industry these people end up going into after they leave the university. So this 1940 number takes students who graduate the university between 1930 and 1935, links them to the 1940 census, and tries to get a sense of, okay, what are they doing now that they have a college degree? So you can see the largest measurable segment here is in retail and wholesale, and then in manufacturing. There are a pretty large number here in K-12 education, and then, I don't know, a number of other areas. This is then compared to the industrial composition of Berkeley students in 2010. Okay, a couple of big changes. Higher ed is essentially non-existent here. It grows very substantially. K-12 shrinks a lot. This other group, you can see that the other group used to be a lot bigger. The degree to which it's bigger is essentially transportation. This is the railroads. Right, we aren't sending people to the railroads anymore. Other shrinks. You can see finance actually shrinks a little bit. This may go against some popular conception. Whereas, so manufacturing also shrinks. Engineering here shrinks, but that's wrong. You shouldn't see it that way because this is a new field, tech, and that increases from nothing to almost 10% of students. If you add that to engineering, you can see that engineering has grown pretty substantially. So there's a sense of how sort of what these students end up doing has changed over time. I'm going to switch for a couple of minutes to talk about faculty, and then I'll talk about the course distribution at the school. So this is the proportion of faculty members who are female at Berkeley, UCLA, and Stanford from 1900 to present. The first thing that I should explain is this. So you'll notice that UCLA, when it was founded in 1922, had more than 20% of its faculty as women. You should take that with a grain of salt. So UCLA had been a 2-year teachers college that transitioned into a 4-year university, but kept the teachers college around for a number of years. The teachers college then had a lot of practitioner teachers, people who taught K-12 during the day and then taught at the college in the evening, and many of those teachers were women. As the teachers college was phased out and UCLA became a standard 4-year university, it reverted to essentially the Berkeley level, though you'll see even in the 60s and 70s, UCLA had more female faculty than both Stanford and Berkeley, and that's still true of Berkeley just about today. I think the numbers go until about 2011. The next thing I think that's very noticeable is, so the first faculty, female faculty in the state, were hired at Berkeley in the early 1900s. And if you look today, so Stanford's numbers inconveniently end in 2000. This is because they switched to an only online model and stopped publishing faculty lists. But if you look as late as 2000, there are far, far more proportionally female faculty at Berkeley and UCLA than there are at Stanford. throughout time, these numbers have largely tracked each other between Berkeley and Stanford. That's what's happening with faculty. Here's what's happening with the fields that faculty teach in. So you should see the width of each of these areas as the proportion of faculty who are in each of these areas. The way this chart works is if there's a faculty member who's dually listed between two departments, that faculty member will be double counted. So you could have one person in multiple groups, or indeed, you could have, say, a single engineering professor who is counted in multiple engineering departments. This is for technical reasons. It's difficult to find these people and eliminate them. Nevertheless, I don't know, let's see, what's most notable here? So you can see here in the late 1910s, the growth of the professional schools. This is a very large increase in the size of the medical school, though that was eventually spun off into UCSF. This is in San Francisco. The business school is also expanding at this time. You can see this tremendous increase in engineering in the 1950s. This is, I think, probably easily characterized as like the Sputnik effect, or the buildup of engineering technology after the Second World War. It dies off in the late 1980s, so there's a sense in which engineering, though you can see it's been growing since the late 1980s, is still far below its maximum, which happened in the middle of the century. If you were to weight this by, say, the number of students taking classes, this would look quite different. You can see the humanities have shrunk. Let's see, so they were at about 30% of students in the early 20th century, and are now only about 20% of faculty now. It's shrunk, but it hasn't shrunk tremendously, by about a third of its size. Social sciences have been roughly stagnant through this period, and professional schools have varied widely, but at least compared to their 1900 levels, are roughly similar. Maybe it's only slightly expanded. I'll flip back and forth between these slides in a moment, but you can do a similar set of slides for the distribution of courses taught at Berkeley. So the way this works, these are not courses weighted by the number of students. This is just, is a certain course taught in a certain year? How many of those courses are in each of these fields? So, so here, you can see a very substantial increase in professional schools over the last 100 years. A lot of this is, well, in this school, which didn't exist 100 years ago, and in other master's level professional schools that have grown over time. You can see here the humanities has not shrunk, despite the fact that its faculty has, which is to say humanities faculty are teaching more than they were 100 years ago. Engineering has this similar increase and decrease, but today it's still relatively high, etc. So the last thing I'll show you about just these sort of descriptive findings is a couple of facts about department formation. So this is again just focused on Berkeley. This just shows the year in which various departments were founded, sort of grouping departments together by type interest. There are only 2 departments marked here with asterisks. These are departments that no longer exist. They were founded and eventually unfounded. But there's a sense in which you can sort of tell a social history of the state using just when these departments were founded. So earliest, you can see this growth of the social sciences, which were created in the early 20th century. Economics was only here about 1898, 2 or 3 years earlier. Most of these were split out of the philosophy department. Economics, psychology, and to some degree political science had been philosophers. Following that period, you see this area of what I think could best be sort of broadly described as urban planning or urban subjects, which come about in the 30s and 40s. Following that, here in the 50s and 60s, as well as the early 70s, you have the growth, again, sort of the Sputnik effect, this growth of engineering professions. And then in the 80s and 90s, growth in ethnic studies, which have now, to some degree, compressed into each other. So just, again, to give you just a sense of how these universities have changed over time.
Where's education?
So, if I had planned this slide more carefully, I should have included the Department of Education. Actually, the reason it's not included is that it's a college, not a major, and I actually don't know when the college was founded. I would like to. If anybody knows, shout out. So, that's the last that I'm going to say in these descriptive analyses. I'm now just going to move into one small piece of analysis that uses this data. This will probably just take another 15-20 minutes, and then if people have questions, I'd love to chat afterwards. So what I'm going to focus on for the last 15 minutes is high school teacher role model effects. Here's the way this works. This is a map. That date is wrong. That should say 1910, sorry. This is a map of California in 1910, where each circle represents a high school in the state. It's also a pie chart. It's a pie chart with 3 sections showing the proportion of teachers at that high school who had degrees from the University of California, from some other university, or who did not have a degree at all. So in 1910, if you were teaching a core academic subject, you were required to have a 4-year degree as well as a 5th-year certification. If you were teaching an elective subject, or if you were in physical education, etc., you did not need to have a university degree at all, not even a 2-year degree. So you'll see, first of all, that there were a lot of high schools in the state of California. In 1910, I think there were 280 of them. You'll see, second of all, that especially in the Bay Area in Northern California, a majority of teachers, or at least a majority of teachers who have college degrees, were trained here at the University of California at Berkeley. This was prior to the opening of UCLA, so this is the only University of California campus. Though you'll notice that down in LA, a far smaller proportion of teachers had UC degrees. This is again because these students were getting certified locally rather than coming up to Berkeley for training. Yes?
So the Cal State
Yeah.
started apparently in 1857.
That's right.
Googled it. So
Yes.
would they be under other universities?
Yeah, so importantly, the Cal States, so I think the earliest was in San Jose, and then Chico, and several others existed at this time. The Cal States were not certified to teach high school teachers. The Cal States provided teachers to elementary and middle schools, but they were only 2-year degrees, and you needed a 4-year degree to teach high school. So Cal States could not teach high school teachers, I think, until the 1940s. So they're not included here at all.
You had to go to UC again.
A UC or a 4-year private university.
Okay.
But you had to have a 4-year degree, yes. Yeah.
I have information for education. In
Oh.
1889, the UC Regents announced the intention to establish a course of instruction in the science and art of teaching.
Okay.
1892, Elmer Ellsworth Brown is hired as the first professor of the science and art of teaching. The Department of Pedagogy is established with a BA degree in education, and it's offered through the College of Letters and Science. The first high school teaching certificate is awarded in 1894.
Yeah.
The Department of Pedagogy grants its first PhD to Millicent Washburn Shin in 1898, and the Department of Education is established under the grad division in 1900.
Okay, cool. So it was a different problem than I thought. I thought that it didn't appear as a department. Actually, it just predates all of these majors.
Predates it.
Yeah, that's very cool. So this is what the education of teachers looked like in the early 20th century. Actually, just as an interesting fact, I'll mention one other thing about the Cal State. So a couple of weeks ago, I was down at San Jose State. And San Jose State, in the as late as the 1920s and 30s, would publish annual alumni directories so that you can see, for anyone who has ever attended San Jose State, if they are currently teaching high school and where they're teaching, if they're teaching. So you'll have the name of the person, you'll have the town they live in, and then you'll see one of 3 options. They're either teaching, not teaching, or married. This is so peculiar. Through the early 1920s, California had what they called bar laws that prohibited married women from teaching in public schools. I'll actually show you some evidence of this in a moment. Many teachers would go get a 4-year degree, certify themselves to teach high school, go teach high school for like 2 years, and then retire. So female teachers had a very, very quick turnaround. And I'll show you, at the median, they taught for 2.5 years, up until the early 1920s. So what I'm going to show you is that while there are estimable role model effects from these female teachers arriving in towns, they're very short-lived. They're very short-lived exactly because the teachers themselves as professionals are short-lived. Yes?
When was this law until?
Sorry, what?
When was this law until?
Oh, I think they repealed the bar laws in the early 1920s, though it may have been the late teens. It was ultimately repealed, I think, because of the First World War. There was a tremendous amount of women who entered high school teaching when the men disappeared, and then those women were being pushed out of high school teaching in the early 1920s when the men returned, at which point the bar laws were repealed. So here's these high schools in 1910. Here they are in 1920. You'll see there are a couple of new schools that appeared between the two. And this just shows the proportion of teachers who are male or female across the state. Darker means more male, lighter means more female. Though the first thing you'll notice is that this lightest component, so 20% of schools, have between, 42 and 100% of their teachers male, which is to say most high school teachers at this time were female. Right? The way these quintiles work out, darker means more female, but even these lightest schools have a large number of female teachers. The reason I put this map up is to show you that, again, if you compare urban to rural areas, there are differences. In tendency, you'll see these dots, I think, are slightly lighter than these dots. They have more male teachers. But the differences are pretty small. There are a lot of male and female teachers in urban and rural areas in California throughout this period. So here's the way this chart works. There are 3 lines. This chart runs from 1903 to 1923 and shows the proportion of math, science, and what I'm going to call phychem, or physics and chemistry combined, teachers who, this is again mislabeled, ignore that. This is the proportion, no, this is not mislabeled, this is right. Proportion of these teachers who are male. So these are the 3 fields that had the most male teachers of any field. Almost all history teachers, not all, but most English teachers were female. But you'll see that among math teachers, about 50% of teachers were male. For science teachers broadly, more than 60% of teachers were male. And restricting to physics and chemistry, the most male field, more than 70% of teachers through this period were male. So this chart then shows you that, okay, the total number of schools is, high schools in the state is increasing, as is the total number of high schools that at least taught physics or chemistry through this period. There were some high schools that, for instance, didn't teach higher level courses and actually were ineligible to send students to the university at all because they didn't teach these fields. Nevertheless, these small schools were the only school available in certain communities. But this dotted line here shows the number of towns that had a high school that had a woman teaching physics or chemistry. And you can see that that's slowly growing through this period. You can sort of imagine what's happening here. I'm going to skip a slide. Oh, I don't show it here. Too bad. Well, you can sort of imagine what's happening. There's a sort of slow diffusion of female STEM educators from urban areas into rural areas through the early 20th century. Every year there are a couple, actually about 4, new towns that for the first time have a female physics or chemistry teacher in that town. And that physics and chemistry teacher will last on average 2.5 years and then switch. In tendency, switch back to a male teacher. Nevertheless, that town for the first time has this female educator. So the question that I'm going to pose is, okay, the town hires a female physics and chemistry teacher for the first time. How does that affect college going from that town? This chart just shows you something similar is happening with doctors. So just like there's a slow diffusion of female physics and chemistry teachers, there's a slow diffusion of female doctors across towns in California. And again, this map just shows that slow diffusion of female doctors. The lighter the dot, the later in time that town got its first female doctor. You could get almost the same exact map for female high school teachers. You see this sort of slow diffusion away from the urban center, which are very dark. They had female doctors early, towards the periphery, which got female doctors much later. As an economist, I'm obligated whenever giving a presentation to include one regression table, one regression slide. So I'm not going to say so much about this. What I'm going to do is run a straightforward linear regression. with town and year fixed effects and controlling for changes in town population over time. The idea is to isolate the year in which a town obtains its first female chemistry or physics teacher, and to look 1, 5, and 10 years after that teacher arrives to get a sense of how college going among men and women changes in those years. So I'm sort of lining all towns up based on the year they get their first female teacher, conditional on their ever obtaining this first female teacher, looking in the years before and after of this year 0 to get a sense of what's happening to college going in those towns. So there's a lot of numbers. I'm going to just ask you to look at this one, and at least for now, ignore the rest. The column says that the dependent variable here is an indicator for whether your town sends at least one woman to college 1 year after the first female teacher arrives in this town. So what this coefficient suggests is that the likelihood of your town sending at least one woman to college the first year that this female teacher arrives increases by about 12 percentage points. If you look 5 years after the teacher arrives, so this is on average over the following 5 years, the increase in the likelihood of at least one woman attending college from that town is about 5 percentage points and remains statistically significant. Over the next 10 years, you can see it drifts into insignificance. This has a p-value of about 0.2. Moreover, if you look 1 year after the teacher arrives at the proportion of students who are going to college from that town who are proportion who are male, that coefficient drops by 13 percentage points, which is to say the kind of student who's going to college becomes more female the year after this female physics and chemistry teacher arrives. And that too persists over the 5 years following the female teacher's arrival. You can do similar tables for female doctors. I don't think, I just included a robustness slide. I won't go through this, but this just focuses on this 12% increase in likelihood and tries a bunch of different specifications. It increases at both public and private universities. It increases even if you avoid the World War I years where college going got a little odd. This is a robust effect in the sense that many different specifications give the same result. But I don't think showing more results like this are particularly helpful. The general fact stands. The arrival of these female teachers was pretty impactful in these small rural communities, right? So the counterfactual you should be imagining here is there's a 15-year-old young woman at a high school in a small California town. This woman is wondering whether to go to college. She gets to her senior year, and that year, there's a female STEM educator for the first time. The presence of that STEM educator just for that single year increases those senior women's likelihood of attending college immediately after high school. Yes?
So how do you factor in the notion that these women also only stay in teaching for 2.5 years when they're trying to go 5 years out?
Yeah.
Those students would not even have seen her.
Correct.
She
That's
had
right.
a picture on the wall.
Yeah. So this 5-year number is a bit misleading. This is taking the average over the 5 years after the teacher arrives, looking each year whether there's an increase. And you can see a lot of this effect may just be driven by the first year. Years 2 through 5 may not be very impactful exactly because the female educator has left. Here's one way of exhibiting that fact. So the way this chart works, this is estimating an effect every year after the teacher arrives. Here's year 0, year 1, year 2, etc. And the gray bars are 95% confidence intervals. So if you estimate this every year, first of all, you lose a lot of power. The sample isn't quite large enough to do this kind of analysis. The standard errors are very large. What you should notice is that the only time the impact is statistically significant is the single year after the teacher arrives. After that, maybe on average, this line is a bit higher than this line, but that's very difficult statistically to detect. The real impact happens the year the teacher arrives, exactly because, by this time, the teacher is gone. That's right. That's not the case, for instance, for female doctors. So this is a similar plot looking for female doctors. You can see there's very little immediate impact. The arrival of the first female doctor in a town doesn't very much change seniors who may have only met this doctor once or perhaps never at all. but there's this sort of growing effect over time. Female doctors were, of course, allowed to practice as married women and tended to stay in town for a long time. So you can imagine, say, these girls here. These girls have had that female doctor for the last 6 or 7 years. And so the impact of these female doctors grows over time as they spend more time in a town with patients. That's not the case for teachers because teachers disappear. With that, oh yes?
I'm wondering, this might be hard to do, but can you track so you track where the teacher is working and you track that address to the student who are actually going into university, the female student, and then link that to what major they study. Is that possible to do?
Yes, so let's see if I include it here. So these last columns, I didn't talk about them because it turns out I actually don't find any effect. But right, there's an initial, I agree, a sort of natural next question to ask is, does this change the proportion of male and female students from the town who end up themselves going into physics and chemistry after having this female teacher? You'll see there's really no impact on women going into physics and chemistry. This is much smaller than standard error. If anything, this seems to be what happens. Men seem to leave physics and chemistry following having had a female chemistry or physics teacher in their senior year. Though the effect is only marginally statistically significant, it's quite small. So that's the best answer I have to that question. There's no effect from doctors on major selection. So with that, I'll conclude. The idea today was just sort of to throw at you as much as I could, to give you a sense of the data that is available and to some degree has been collected, a sense of what this data looks like, and then finally a sense of what can be done with it, what kinds of statistical analysis could be used to learn something about college going in the early 20th century. Most of the data that I presented today will go public at the beginning of next year, I think on January 1st. So we're building a website right now around the sesquicentennial, the 150th anniversary of the university. And so these all will just be posted online for people to use, as well as a number of these interactives. A lot of what I showed you today actually was originally built as interactive figures so that people can go in and look at whatever particularly interests them across campuses, across gender, etc. And then, of course, there's a lot of analysis that can be done on this, some of which I'm planning on doing, and some of which I'm hoping by putting these out into the world, other people will find interesting and do themselves. So with that, I'll conclude, and would love to answer questions if you've got them. And if you don't, then we're done.
My question takes us off track. But,
Sure, that's great.
As a statistician, how do you feel about high school's capstone math courses being sort of like calculus rather than statistics? It seems like statistics would be a lot more useful for students than calculus.
That's a good question. To some degree, it will depend on the field. I know in my own field that it's actually similar to this capstone program. My own field values mathematical skill far above its usefulness in the field. Statistics is what people ought to be learning. I don't think that I have a very insightful answer to that, other than to say I would have been helped tremendously by learning statistics in high school. I think I was ill-served by not. But yeah, that's the best that I've got. I don't know if there have been examples of high schools, I don't think there have been examples of high schools that have switched to a capstone statistics model. That's the problem. So I think it would be tremendously useful from a policy perspective if high schools were allowed to switch. And then we could look at outcomes for students. My sense is that it would be possible. Yeah.
Did you see, or did you all follow any trends with what degree women got and when they got married?
Yeah. I don't have a way of observing that yet, and I'm really interested in that question. So the way the data work right now, I see when these kids are in school, I see what major they get, and then for alumni records, I can sort of jump to the 1940 census and check in them then. The 1940 census will tell me whether the woman is married, but it won't tell me when she got married. It will also tell me how many children she has, conditional on her continuing to live with those children. But it won't tell me, and actually it will tell me when she had those kids, because it will tell me the kid's age. But yeah, so there's some timing information that's available and some that's not. There aren't very many people in the world who study the history of higher education. There are a lot of people who study the history of K-12 education, but universities is a niche market. There's a woman named Claudia Golden who's at Harvard, who's done, I think, some really interesting work on this question. What she's interested in is the change in fertility rates, and marriage rates overall in women as higher education has grown in popularity. At this time, almost half of women who went to college ended up never married. That's which is unusual for the time. If you've seen, there's a British movie, An Education, that describes college going in the 30s that has characters of that type. So she's done a lot of work on this. When I sent this work to her, that was the immediate question that she asked, and I'd love to be able to sort of get a better handle on it, and I don't. Okay, oh, yes.
So I know you collected, you're looking at historical data, so are there any plans from either the Center for Studies of Higher Ed or UCOP to collect ethnic data, the impact of not just gender, but also different ethnicities in terms of its influence in the communities?
Yeah. So campuses tended to not collect any ethnic information until the early 1990s. I know, for instance, that UCSF started collecting in 1991. I don't think Berkeley has information until late 1980s, but prior to that, campuses did not collect this information. For instance, right, there's no information on students' transcripts or even on internal records. I'm very interested, as was brought up earlier, in linking these students to the census or machine learning information about them that can give some sense of ethnic communities over time and their participation in higher education, as well as the quality, what was happening in that education. But we're going to be limited by available data. Yeah. Yes, sure. Yeah.
So, I understand. So, the data wasn't collected until, say, 1990s or so. So, does that mean that the data would be available to analyze starting as far behind as like 1995 or something, and going forward?
Correct. I'm very actively working on a project around Prop 209 and the end of affirmative action at the UCs, which occurred in 1997 and 1998. And it is convenient that although ethnic information only goes back to the early 1990s, at least it goes back for a couple of years before Prop 209. So yes, I think we can very efficiently study the impact of the end of affirmative action at Berkeley, other public universities, and elsewhere. Yes?
So that's interesting to me that that the data about ethnicity was not tracked for a large part of the affirmative action. Is that what you're saying?
Correct. Yeah, that's right. So, yes. This information was collected on applications, and then once we started student records, the information was no longer kept. And moreover, application information was not centrally organized. That tends to have been destroyed over time. That's exactly right. There's a sense in which, right, it was exactly collected for this narrow purpose. And because there was no purpose once these students were students at the university, they didn't maintain the record. Yeah.
So maybe we have kind of data of the campus at large, but not which individual students, like matching students their ethnicity, or?
That's a good question. I have never even seen aggregate statistics of ethnic composition of the university prior to 1990. It could plausibly have been calculated at the time. I'm not sure it was, and I'm not sure the records were kept. I've never seen it. Yeah. Yeah. Yes?
I just was wondering if this work or work like this is being used to influence conversations about how records are kept from now
Yeah.
and into the future, and if you could speak about that a
So
little bit.
sure. So the first time I gave this talk, actually, so one time before Lisa saw it in the spring, I gave the talk to the California Digital Library, which is an organization that it's sort of like the central library of the University of California system. It's based down in Oakland. And that was the first question that they asked is, right, first of all, how am I storing this information? And second of all, what can be done to preserve this kind of information that's being available to researchers in the future? So to the degree that I'm talking to librarians who are not the producers of data, but the storers of data, I've done as much as I can to make sure that these data are collected. I haven't done any work, for instance, right, talking to folks who create course catalogs and preserving data that was collected in course catalogs, et cetera. That's an interesting avenue, but it's not something that I've done anything. Talking to librarians is in general very fun and often very productive. And yes, that I've done a lot of. Okay, I'll call it there. Thanks all very much.